There are 4 chord theorems. The first one says this: chords of equal length subtend equal angles at the centre of the circle. That's to say, if this chord is the same length as this chord, then this angle is the same as this angle. Can you see why that is? These 4 are radii of the circle. They are all the same length. If this length and this length are the same as this one and this one, and this third side of the triangle equals this third side of this other triangle, then these 2 triangles are congruent. They are the same triangle, which means they have the same centre angle here. The second chord theorem says chords of equal length are equidistant from the centre. So if this chord is the same distance as this chord from the centre, if those 2 distances are equal, then this chord is the same length as that chord. Conversely, and I think I've actually said it the opposite order from what they did, if this chord is the same length as this chord, then they are the same distance from the centre. Now, to do that, you have to remember that to get the distance of a line from a point, you're going at right angles. That also tells you something about one of the theorems coming up. The third chord theorem says that the perpendicular from the centre of the circle to the chord, it's perpendicular to that chord, bisects the chord, cuts the chord in half, and also bisects the angle at the centre subtended by that chord. So, if it's perpendicular from the centre to the chord, then it's cut the chord in half and it's cut that angle in half. Conversely, if you have 2 equal angles and 2 equal halves of the chord, actually, you can have either of those conditions, then this line going down must be perpendicular to that chord. The fourth chord theorem says perpendicular bisectors, so they are lines that are perpendicular to the chords. All the bisectors that are perpendicular will meet at the centre of the circle. So to find the centre of the circle, make 2 chords, cut them in half at right angles, and you will find the centre of the circle. Let me see if I can show you that last one on the TIS Biographics calculator. Again, I've just got a document with a geometry page. Start with a circle. Draw the centre and draw it out. Then I want to have segment because I want to have 2 chords on my circle. It doesn't matter where you put them. Now the perpendicular bisector of each of those chords is going to go through the centre. The graphics calculator can help you. Construction, perpendicular bisector. So I'm going to cut this one in half and this one in half. This one already gets to the centre. I may have to extend this one. I can do that easily. Press Escape to get just back to the pointer. You can grab the end of that line and drag it out. And wherever I move that chord, anywhere, the perpendicular bisector goes through the centre. So if I've got 2 chords and I get a perpendicular bisector through both, I will find the centre of the circle.